So in this video you can see I'm showing this symbol and it's having this this category and to detect the particular symbols, right? So it's showing home and like you can see it's having this kind of recognition, object recognition code. So this is the ASL language and having ASL kind of for different animations, right? So how to do that? I'm having this code and different values for the scene. So let's take for another symbol. Let's take for YOLO version 7 for another language. Let's say love. So for this we have images, and these images saying that we will have to specify these images and all these. You'll have to show this symbol and all, right? You'll have to show this symbol like this one. So this is the symbol for love. So we are going to train these for custom images and train for the annotation part for the different images. For this, how would I'll take the another file for Python and will import the first library, that is import for my another different values. So this is import OS, and then I'll take the another library called import CV2 for my CV2 version library, opening the camera and opening the mic and everything. So then I'm going to import the time library for the another capturing. Let's say I'm having capture variable for open the default camera. So it's going to CV2 dot video capture. So by default it's my webcam is having value 0, so I'm going to give the parameter 0, and then I'm having second parameter set the different folder and resolution for my camera. So for this I'll going to cap dot set, and I'm going to define this CV2 dot another function. So these parameters are just going to say for the dimension. Let's say this is having first CAP and the prop, and then we have frame width. So along with the frame width WTH, I am having this dimension as 640. I am setting this 640. The same I'll do for the height. I'm going to copy this code and just hit enter, and frame width I'm going to set HEIGHT as a height. So now I'm setting the create a folder to store the images. I'm setting that folder is equal to images, and then I'm going to set the path, right? If this file is not existing, then if os.path.exists exist with the certain folder. If it is not true, then it should create the directory os.make dir, make the directory with the name of folder, right? Else it will go with the continuous fashion. Now I'm going to set the interval between captures in seconds. This is intervals. So interval is equal to 5. After 5 seconds I want to capture from my video camera, that is webcam. So while it is true, while this condition is true, I'm going to set this option and then set a frame from the camera. I'm going to set ret and frame, and then is equal to CA import. So this CA import, I'm going to read something. So this is the read function. I want to capture a frame from the camera. If frame was successful, then it will print something like if ret is successful. So I'm going to set this one. So it is generating a file from the image. I'm saying file name is equal to os dot path dot join, and then along with this folder I'm going to read f, and then I'm going to set the time dot time, and then the square round brackets, and then with the extension of jpg. It should be the format of jpg. I'm going to set enclosing the brackets. Right now save the image to the disk. I'll use cv2 function. So cv2 dot im write. So with the im write, I'm going to pass the file name, and I'm going to write all the frames, whatever the frame it's going to capture. So after this if condition, I'm going to pass another thing, wait for specified interval before capturing the next image. So this is the time dot sleep. I'm going to perform the sleep and the interval value, right? So the interval is having 5 as of now. I'm going to keep it in a sleep mode. Then perform the second cv2 function, that is the if cv2 dot wait key, and then wait key is equal to 1, and then I'm going to set the another parameter, that is o x ff is equal to, if this value from the keyboard is something nearby by q. If the user will press q, it will go to the halt sector. So I'm going to press break, and this will be import there, right? So I'm going to break the entire statement, right? Eventually I'm going to release the camera and close the window. So this is by cap dot release, and then round bracket, and I'm going to cv2 dot destroy window, destroy all windows, right? It is going to run the code. I'm going to run the code. If it is any, right, p dot there is an error, p dot read, right? We should have this value, right? So here you can see I just by mistake I had shown the, I had written the cap import, but actually it is cap.read. So now it's successfully run. cv2 had no wait key, so I'm going to run this code again. Now you can see it's just going to save the images. If you'll open this file, it's just showing the images over here, right? So inside the images you will have to show the center values. You can see after each 5 seconds it's just capturing the images and storing anywhere, right? So you will have to create this value and this one, right? Make sure we have more values here. So I am going to run this code again, right? Alright, so you can see after each images, after each 5 seconds this images has filled, is pushing all these cameras images. By after 5 seconds it's going to click all the images, and what's my responsibility here to just make sure I'm having that posture, right? So it is showing like this one, it must have this one, just make sure you have different elements. And also, right, if you'll check the last value, so my image is like this one, right? This is having this entire value, right? So I'm going to again capture the image. I'm asking to the webcam to take my images and the capture value, right? You can see I'm showing the correct movement, correct symbol, and if it will have the love symbol, so it will show the current position inside the possible solutions. Now you can see in my certain folder I'm having custom dataset. The symbol showing here is almost equivalent to love symbol, right? If you have empty dataset, or if you have another part, you can remove that image and you can I mean delete that images, right? But keep only the relevant dataset here, right? So what I'll do, what's my next step? I'll go to the next website. Here I am having the Yolov8 sign language image dataset, where I had trained the home symbol for my 16 images. I'll do the same for my another class, right? So I'm going to like this one, I'm going to upload the images again. So now this is asking for the select images. So previously I had selected my home symbol custom dataset. This time I'm going to select the love sign. So I'm going to open this file. So this is the Roboflow. If you don't have credential for the same, you will have to create the credentials. So you can use your Google account also in order to provide, and just go to the invitees and go to the custom invite settings and create new projects. So if you will create new project, it will ask object detection, boundary box, single level classification, or multiplication. So we are doing for object detection, boundary box. We are having this kind of realistic project. So what we are going to detect it, you will have to mention sign to text conversion and project name Yolov8 sign language, and license you can choose anyone and create public project, right? It will be available publicly. So this I have done. I am not going to repeat it. So for all 26 images, just import it, and I'm going to save. Click on save and continue. So when I'll click on save and continue, it's going to upload my files. So once they are uploading, it will ask for the annotation part, right? So I'm going to assign images. Okay, all 26 images are here. So I'm going to assign images. So again, start, it's asking to start annotating. Yes, I'm going to start annotating, right? So for the classes, I'm going to insert, like this one is the symbol, and I'm going to make a small box over here, and class this time I'm going to keep it LOVE and save enter, right? So this thing I'll going to repeat for all my images, this one, and save enter. I'm going to pause this video so that you don't have this repeating word, and you can do for the same all these 26 element. Now you can see my version 8 is just over here, and this is the version values, and this is the version 8. So I'm going to assign and annotate, right? You can see annotating to dataset all 26 images and this label 26. So all 26 images are annotated. You can see I have annotated all the images over here, and you can see if you click over the single image, you can see all my 26 images having this part, right? You can go to the previous page and add 26 to the dataset, right? So you can change the test and valid dataset for the train, valid, and testing. So as of now, I'm going to test for 0%, and then rest 10% for my validation, 90% for, so keeping more and more images for my training. So because I'm going to test using my webcam, so I don't want to keep the more images inside the valid. So this is 93% for train and 1 images for this one. Now I'm going to add the second class and generate a new version and dataset 2, and this is going to generate new version. So here I'm going to generate new version. You can see this is the third version. I'm going to generate 47 images, 2 classes, 2, one is for home, second one is for love. So I'm going to train the images and validation part over here. You can go for the pre-processing part, like for example you want to perform the auto orientation. If the given image is for any changes occurs, an implementation part over there, so you can it can detect their images also. You can add more pre-processing part here, like setting crop and auto adjust contrast, grayscale, resize, and etc. So as of now I'm going to keep it as simple. And when, as far as augmentation part is concerned, you can add augmentation part 90°, right? Suppose you have 90° clockwise, counter clockwise, you can add both these instances. You can change the orientations also, like suppose add orientation, and I'm going to rotation for some custom angle. So I'm going to keep 30°, 45°, or anything 0° or 10°, right? You can make more number of images while training. So I'm not going to keep the augmented here, just keeping this part and just continue. So this is going to see how this is calculated. So maximum size is 47. I am going to keep this one. So I am going to generate this one. So this new version is just created, and my next part will be to export this into the certain value. So you can export for your purpose, for your Python file, for your Jupyter notebook, for your NVIDIA processor, and anything. You can have that glimpse value, right? So it's generating, the new dataset is creating, and it takes a few minutes as a machine is spin up to process all the images. You can see my images are over here, right? 2 images, and we have images, and for different values. You can see some are having home, some are representing second class, and other images, right? 20, and I'm going to get a snippet for value YOLO version 8. I'm going to export. You can go to the export, and you can select the another version, another XML file, Coco model, previous YOLO version, but I'm going to select YOLO version 8, show download code, and continue. Now you have the credentials for the same, your input Roboflow and Roboflow. I'm going to copy this code and just close this tab. Now coming back to the export part, where we have the expression YOLO version and everything. So just go to the collab. So in the collab search, we are going to implement all these value. So I am going to import new notebook here, and saving the rest credentials for taken from Roboflow website. So I'm just pasting it here. I'll use it in upcoming sessions, upcoming code. I'm going commenting it, right? So first I'm going to import my NVIDIA. So that is NVIDIA processor. I'm going to activate this NVIDIA processor SMI. So if you run this code, you will find some activation part for SMI driver version, CUDA version. So latest CUDA version. Make sure you have runtime. You can change runtime here. No, it is not set to GPU. You will have to convert into the GPU. Yes, I'm going to save it over here. So you can activate your Tesla and GPU file persistency, display, and valid anything over there, right? I'm going to activate the another functions, like, so the next I'm going to install pip. Okay, so I'm going to install it again. Pip install okay, so pip install Ultralytics. That is the next I'm going to install over here, right? You can install over here. Now I'm going to check the another values for this one, for the another requirements. For this I'm going to import from Ultralytics. I'm going to import YOLO, and then I'm going to import the next thing. I'm going to import OS file, and then the second thing I'm going to from IPython.display I'm going to import the image and then the display part, how I am going to display the entire output. So the next thing I'm going to import IPython. I'm going to import display. I have taken there that part, and just I'm going to import display dot clear underscore output, right? So that I'm going to import, right? Then I'm going to import Yolov8 and then run this code. You can see these Alternative Yolov8. So we have Alternative part cannot import version because some version and options and opens are there. Okay, so we can check for the another values. We can go for the another. Now you can see I had installed the pip install Alternative, and this is having next file from IPython import display and display clear outs, just checking the different outputs. So I'm going to import this one, right? If you don't have Alternative, you will have to install this one, and then downloads the Python 3.9.16 torch and QDAV values, right? So this is going to install the Alternative. I'm going to install the Alternative again. It's going to using hash pip install Alternative, and then it's downloading the supporting files, right? Once it is downloaded in your local machine, so you can run the from Alternative from YOLO and IPython display import image and display, and the from import by Python import display and display clear outs, which clears out all the different outputs, right? So the second things, I'm going to import the Roboflow. So it is pip install Roboflow. So I'm going to run this code. So this will ask to restart your session, restart your entire IPy file. So you will have to reload the entire dataset again in order to successfully build vjit and other files. So you can see this is asking to restart runtime. I'll click over the restart. Yes, I want to restart it again. So it's going to restart. You can see initializing over here, and then I'm going to rerun all the initial steps again. So pip install Alternative, I'm going to pip install Alternative here, and then I'm going to run the image Python file, cpy file, and then I'm going to continue the relevant code. So this is just keep it below, and then I'm going to provide the another credentials, right? So I'm going to get export from the YOLO version 8 show download code. I'm going to copy this from this one and just paste it over here. So you can see I had already pip installed Roboflow. I'm not going to install it again, and this is my API key workspace. This is the folder name and project Yolov8 sign language and the version name. I'm going to run this code, and it will take time because requirement are going to install in your local machine, and version and are going to install in your desktop. So it will show over here. So all the files are just installed over here, sign language 3, and everything is just over downloaded over here, right? So what I'll do, I'll go to the next YOLO, right? So what is the task over here? I'm going to detect this one. So this is the detect part, and what is the mode of this one? So this is the mode, and I'm going to train model. So this is the model. What is the model over here? This is the model number, this one, right? So the another model we are going to train over here, right? You can see this model is just downloaded over here, right? Right, so this we have just downloaded over here. Okay, so you can go to the upper side, Yolo version 8. Yes, we had installs, right? You can see set complete to CPUs, and now we are going to install the pip install function, right? You can go to the Yolov8, and inside the Yolov8 we have certain test images and certain train images and the another images value. So Yolov8 we have that certain model. So then we have the data set from where you will get that data. So I'm going to space that data set. So I'm going to provide this data.yml file. I'm going to copy this one, this copy, and then I'm going to provide epochs. How many times I want to run this epochs is equal to, let's say I'm going to give epochs 30. So what is the image size? I'm going to give image size is equal to 640. 640 by 640, I'll give 640 one time, right? So this is having image, and I'm going to detect the model and train the model, and then how to import that this one. So you can go for the Yolo website. Okay, so I'm going to click over here. So if you will go to the Yolo v8, so this is the official GitHub page of Yolo version 8. If you'll go search for the Yolo different training models, right, predefined models, you can see it's a Yolo v8 over here. We have Yolo v8 v86, right, and the image pixels is 640 over here. If you click over here, open a new tab, so it's just going to download in your local machine, right? This is just going to download over here. So it's already downloaded, so I can upload here. So you can upload here and go to the download section, Yolo v8s point, and click over here. So once it is downloaded in my local drive, so I can paste it over inside after the model function, right? So you can upload over here. Alright, so you can see this is my pip install. I am going to select this browser. So this is the Yolo v8, right? So pip install over here. So if you click over this one, so it will install the necessary files, and we will have the Ultralytics import Yolo. You can see this is just importing the part, right? So I'm going to run this code again, right? Then we will have Roboflow already inbuilt function, uh, right? We have the credential part from the Roboflow, we have taken from the robo site, then we have task, and I'm going to copy this one, copy path, and just paste it inside after the model. So I'm going to paste it here. It will automatically detect the content and then Yolo v8 point. So this is predefined file. So epoch 330 and image size. I am going to run this code, and if it is not showing any error, it will run successfully, and you can see it's the runtime error file unrun. So it's going to check the task, detect, it will have the model train, and then we have model content ds point data is equal to content v6 YAML, right? So it must have this language, this YAML file, and then we have epochs and then image size, right? Now you can see this is going to uh, train all my epochs, and this sign is having all the images, data sign Yolo v87, data v8 -2, and Yolo epochs for 30 and image sign. So I'm going to pause this video in order to run this epochs, so it will take half an hour or 1 hour. It depends upon number of images also. So I'm going to take it as pause mode. So now you can see my processing has been completed for 25 epochs, and the train model is just saved in the runs folder. When you click on the left hand side runs, and then I'll click on the detect, and inside the detect I am having train, and the train it will have weights. So if you click on the weights here, so you will find best.pt point, right? So the last point is the last epoch, and the best point we have the best epochs, right? Best accuracy for the different aspect. So you will have to download this best point over here. So it's just downloaded. I have already downloaded. So inside my local machine, this is just best.pt. Now you can export or import this train model in your NVIDIA file, your Visual Studio Code, your Fast API, or your another version. So I had taken a new Jupyter file where I am taking this code, this from Alternative import YOLO. I'm going to detect to predict the detection predictor, and importing from giving the path of this best.pt. So here I am going to show the entire disabled Docker environments and other files. So I'm going to predict this one, and you can see the last code is just showing the model. So if I'm showing this symbol, so this is having a certain model, right? If you can see, it's showing, right? If I'm showing this symbol, so it's showing something different, right? So you can have this value, it's showing home symbol, right? You can see this is the another model, and this is the another symbol for my training value. So the probability is also again for 0.88, 0.44. If I'm going to show this one, so it's having again the different sign. So again the different symbol, you can show the different part. And again if I having this one, so it's having this one. Okay, so this is the realistic example of custom images. If I'm not showing any hand, so it's not giving any class value. So again I'm showing this value, so it's showing the home, that's the probability is 0.45. so this is how you can perform the classification. Model.predict source is equal to 0, that is by default your webcam, show true, and confidence interval is 0.3. if you increase this or confidence interval, the threshold value will increase. You will see the different outputs. Here you can see the no detection, and some other files will have the this one love and other symbols, right? If you decrease the confidence interval 0.1 or 0.25, then you will have different output and accuracy measure, right? You can use this predict model for your threshold values itself. Anywhere you can increase or decrease your performance, right? It's not necessary you just go to the conventional method here and decrease the model and decrease the performance value. If you want to show the F1 curve, you click on the PNG graph. You can see this F1 curve will shown over here. This is the accuracy for both the classes. If you'll go to the PR curve, so that will have the another PNG file in order to depict for your research purpose and another purpose, right? If you'll go to the R curve, it will have the another PNG file for the different values. You can see here we have confidence interval for the different aspect. So thank you so much. We can have the particular aspect. You can close this window over here, and then we can go for the next model. Thank you.